Hi, welcome back to Moose and Chemistry. Today we're going to be working with VSEPR models, and this will be our first lesson, Introduction to VSEPR Modeling. VSEPR modeling is where we take chemical compounds and we put them in three-dimensional structures. So we're going to try our first one, which is bromide triiodide. So now let's first look at this. So bromine is in group 13. So that means it has, you get rid of that one there, it has 3 valence electrons. And I, which is iodine, is in group 17. But we cross out that one there, so we have 7 valence electrons. So now what we need to do first is find the total number of valence electrons for the structure. So what we're going to do is we're going to go B1 times 3 electrons. And then I, we have 3 of those, 3 times 7 electrons. So when we look at the total, we have 3 electrons for bromine and 21 electrons for iodide. So now we add these total together, we get 24 valence electrons. So we're getting there. So now what we need to do is we first put the least electronegative atom in the center, and then we're going to put these eyes around here. So we're going to try to space them out nicely like this. And so now what we're going to do is also remember that over here that a line is equal to 2 dots. And those 2 dots are 2 valence electrons. So let's go ahead and let's count out our electrons. First we have to connect the I's to the B. So 2, 4, 6. So we've used up 6 of our 24 electrons. Now what we need to do is put the rest of the electrons that we have available around the I's. Like this. So now if we had any electrons left over, we would put them back on the core atom. But if you look at this, we have 8 electrons around each of the wraparounds. So 8 times 3 is 24. So now what we need to know is this the best possible structure? So in an earlier lesson, I taught you formal charge. So let's look at the formal charge of bromine first. Remember that formal charge is valence electrons minus non-bonding electrons minus bonding electron pairs. So we're going to put in the fact that boron came in with 3 valence electrons. It has 0 non-bonding electrons because if you look at the boron, all of the bonds are used. So we have 0 bonding electrons. And that means we count our sticks. We have 1, 2, and 3. We have 3 sticks. So with 3. So that gives us a 0. That's good because the closer to 0 for these, the better possibility this is what the structure really looks like. Well, let's check the formal charge for iodine just to make sure. So the formal charge for iodine, okay, again, remember that's valence electrons minus non-bonding electrons minus bonding electron pairs. So now I comes in with 7 valence electrons, and we've got 2, 4, 6 non-bonding electrons around I, and we have 1 bonding pair. So 7 minus 6 minus 1 is 0. And this is also excellent. So this is the best possible structure. However, let's make sure that we know what the VSEPR shape is. So to find that out, what we're going to do is we're going to erase this check mark, of course, here real quickly. Again, I wish I had a bigger eraser. Maybe they'll do that in an update one of these days. So let's count the central atom as A. And then we're going to do each of these I's as X's. Put X's with them. And this is going to be AX3. Now, if you check your VSEPR model molecular shape handout that I've already given you, you will realize that AX3 is a tetrahedral, not tetrahedral, it is a trigonal planar structure. Got too fast in my earlier talking. Sorry about that. Trigonal planar. So knowing that is trigonal planar, I can also look at my handout and realize that my bond angles are 120 degrees around each of these relationships here. And that just so happens to equal 360 degrees if you add it up. So let's try another one. So let me go ahead and erase all the drawings here. So I'm going to erase the drawings, clear them, and we're getting them all cleared. There we go. And our next model is going to be, NF3. So we're going to call that nitrogen trifluoride. Now, nitrogen is in group 15, which means it comes in with 5 valence electrons. And fluorine is in group 17, so it's going to come in with 7 valence electrons. Remember to get rid of the ones here, and that's an easy way to tell you how many valence electrons you have. So now what we need to do is find out the total number of valence electrons. So we look at our nitrogen. We have 1 nitrogen, and each nitrogen brings 5 valence electrons. So our fluorine we got 3 of those, and each fluorine brings in 7 valence electrons. So let's add all this up. We got 5 valence electrons, 21 valence electrons here, which gives me a total of 26 valence electrons. So now we have to determine that our nitrogen is our least electronegative element, so we're going to put that in the center. And of course, we're going to space out our F's. In this case, we're going to put an F here, and F here, and F there. You'll understand why later. So now let's go ahead and use up our 26 electrons. 2, 4, 6. So now we've used up 6 electrons, so we need to finish out our electrons around our wraparound atoms, as I like to call them. And so now when we look at this, we have 24 valence electrons showing there. However, we have to have 26, so our leftover electrons go into the center right there. So now let's see if this is the best possible structure for nitrogen trifluoride. So we're going to do something called formal charge again. So our formal charge for nitrogen is going to be valence electrons minus non-bonding electrons minus bonding electron pairs. So nitrogen has 5 valence electrons. Non-bonding electrons, we can see that there are 2 there. And bonding pairs, we've got 1, 2, 3 of those. So let's get rid of those numbers there real quick. And so we got 3 there, so that gives me 0. That's good. So that's working pretty good so far. So now we have 3 fluorines, but since they all look the same, we only have to do 1 of them. So our valence electrons minus our non-bonding electrons minus our bonding electron pairs. So now if we look at the fluorine atom, fluorine comes in with 7 valence electrons. Non-bonding electrons, 2, 4, and 6. So we have 6 of those. So we're going to put a 6 right there. And our bonding pairs, we have 1, which is right there. Again, I'm going to erase that real quickly. So that gives us 7 minus 6 minus 1, and that also equals 0. So we know that this is the best possible structure. Now, what kind of structure are we really looking at? Okay, so we're going to have to look at this again. We have A in our core, X, X, and X. So far we have an AX3. Oh, look at this. We have an unshared pair of electrons. So we call that AX3E. Sometimes people call this AX3E1. However you want to write it, that's fine. I just call it AX3E. Now that kind of structure is a trigonal pyramidal. So trigonal pyramid And each of these bond angles are exactly 109.5 degrees. Have an amazing day, and look forward to our next model lesson in VSEPRs.